Right, so what we're actually going to go through today is we're going to be doing a walkthrough of a remote lab activity that you can do entirely in SPARKvue. So we're going to hop onto one of the onboard sensors in a device, either in a smartphone or a tablet, and we're going to be measuring acceleration in order to determine G, the acceleration due to gravity. I'm not saying that this is the only app that you can do this in. Sorry, let me just see if I can if I can mute someone. Bear with me. That's me. Here we go. Where was I? Yeah, so this isn't the only app that you can do this in. You can do it in a few different ones. Probably the most popular one out there is an app called Fifox or Fifox. I don't quite know how you say it. But the nice thing about SPARKvue is that you can do all the data collection and data analysis in that one platform. So you don't have to bother exporting the data, which can be quite clunky, especially if you've got students that are easily distracted. If they've got to go from one platform to another, it can be quite a big annoying thing. So that's one of the nice things about SPARKvue, that we can just stay in that app and do everything in there. Again, there's no need to take notes. So I will be emailing out this resource booklet. So you got one of these last time, so this one's just for this session. It's got loads of information, like step-by-step guides of everything that I'm going to do today, with some diagrams. I'm going to do all the maths for you. This isn't quite finished yet, so it's not the finished article. I'm only working a 2-day week at the minute, so I'm struggling to kind of fit everything in. But everything that I'm going to talk through today is in this book. So I'll send you a link on how to download that after the session. So yeah, don't feel like you have to sit there furiously taking notes. I've got you covered. Right, okay, so right, let's get started then, why not? So just as a bit of an introduction, it can be shown that for a pendulum, this relationship exists between the period of that pendulum, the length of the pendulum, and G, the acceleration due to gravity. I think this is a pretty well-known equation. Hopefully you guys will have seen it before. I think you introduce it typically when you're doing things like SHM. And then this equation can be rearranged to show this relationship at the bottom underneath. So this is what we're going to be using. So we're going to determine G by measuring the length, L, of the pendulum, and also measuring the period of that oscillation. Let me just check what's going on here. Anything? Is this aimed at KS5? To be honest, it's kind of aimed wherever. I mean, it's just an activity that you can do completely for free. I think you do SHM, well, you did in my day anyway, at GCSE level. So definitely, probably from at least then. There isn't anything too involved in there, and you can make it as automated as you want to. I mean, the experiment itself is quite easy. You can also extend the exercise as well. I'll talk about ways that you can do that just to make it that little bit more difficult. But I mean, really, the aim of this is to get students to understand that they can explore the world around them using their smart devices, and the ability to take data personally. It's super easy. And I mean, it's all about getting people engaged with doing science on their own terms, and hopefully that will inspire them to take science to a higher level. I think someone else is in the chat. Bear with me 1 second. SHM is A level as well. Okay. Oh right, just instead A level. Okay. Well, that's absolutely great. Yeah, it probably is. It can be quite involved in this experiment and just see, and IB. Yeah, just see what kind of level you think it is when we go through it. I think with different schools as well, you get different ability students, so it all depends on the confidence of your students and where you think it's best placed. Right, so this is the experimental setup. Bear with me 2 seconds. Someone else is coming in. Oh, bingo. Thank you very much for admitting someone. Makes a huge difference. Let me see if I can mute them. Hang on. gosh, I might have already done it. Perfect. Right, so this is the experimental setup. I'm going to switch my camera in a minute so you'll be able to see this view of my staircase. So I've essentially robbed this idea from, it's an article in the American Physics Teacher, I think it is. It's an American journal. They run through exactly the same method that I'm going to today. In the actual article, I don't know if you guys have got access to this journal, but it's not very explicit. So the whole point of today is to make it more explicit and to make it you guys more able to readily and quickly replicate this experiment at home. So this is what my apparatus looks like. This is in my door frame just behind me. So I've got two of those little plastic command hooks attached to the bottom of my door frame. I made sure that I stuck them on for the recommended time to make sure that they could hold, you know, a good amount of weight. My smartphone doesn't weigh very much, but just to make sure it's not going to fall off. And then I've got this string coming down from one hook down to my phone and then back up again on the other side. So in the article, it suggests that you should do you should make the pendulum in this way instead of just having that one solitary string. And the reason for that is so that you don't have your like smartphone rotating about that axis. It just makes it prevents it from doing that, basically. It still can do a bit of a wobble, but you'll probably see that in a minute. The idea is to get the length of this string as long as possible. So you see that I've got like a nice long pendulum here. It just makes sure that we can measure G a bit more accurately. And I think that's pretty much everything I need to explain there. The length L is the distance from the pivot point down to the center of mass, so like halfway through the phone down here, as I've put in this diagram here. Right, so let's go through the demo in SPARKvue. So instead of doing it on my PC this time, I need to do it on my phone because my PC doesn't have that accelerometer sensor in there. So I need to now share the content from my phone, so bear with me 1 second. Let me go back to Teams just so I can see what I am sharing. Share screen. Right, so hopefully now everyone should be able to see my phone screen. If you can't, do you want to just give me a wave? Just so that I know what's going on. Right, okay, no one said anything, so I think we must be okay. So I'm going to come into my SPARKvue app. Would be good if these practicals match the assessed A level. Yep, absolutely, we are going to get onto those. So for the assessed A level ones, it might be easier to use the actual paid for sensors. So for these introductory sessions, I just wanted to show what you can do with the app completely for free. So this would be like a complimentary activity that you could give your students to just to help reinforce what they have learned and maybe expand on what they've learned. That's what the purpose of these sessions are at the moment. So I'm going to open up my SPARKvue app here. And then I want to choose sensor data. So if you want to follow along with this, then absolutely do feel free. So I'm going to tap sensor data. And then I'm going to tap the onboard acceleration sensor, just use that toggle button to turn it on. I'm very aware that you can't see a mouse button on my phone because there is no mouse. You can only see what's happened after I've pressed the button, so I do apologise for that. But I'll try and talk you through as much as possible. So I'm literally just going to press that toggle button for the onboard acceleration sensor. And it's not come up yet on Teams. Let me close it and open it back up again. Lovely. So you can see it can measure acceleration in the X, Y, and Z planes and also the resultant acceleration. So I'm going to just click all of those so I can see everything that it's measuring. And then I'm going to tap on that graph icon on the right-hand side. So this is pulling up 3 different graphs for me, one for the X plane, the Y plane, and the Z plane underneath. And then if I press start, it should just start collecting data for me. I think it's struggling broadcasting the signal as well as collecting data. Hopefully it'll work for me. Let me stop and start it again. bingo, here we go. So now if I shake my phone around a little, you should see the readings start to oscillate. So again, that's just how easy it is to start collecting data in SPARKvue. Super, super easy. And again, if you've already invested in PASCO and you use this app already in your classroom, kids are going to be familiar with it. They're going to understand exactly how to get up and running with it. So doing a remote activity would be super, super easy for them. Also, as well, I know that the government have announced that we're moving back to in-person teaching. Not that that isn't happening at the moment anyway, but for the wider population, it's happening. I think very, very soon. It might still be easier to get students to use their own devices rather than having to use them in schools. Then your technicians don't have to clean everything all the time. So again, just because we're moving back to an in-person setting doesn't necessarily mean that this isn't a relevant activity that you can be doing with your students. So what we need to do is we need to decide which of our planes, those X, Y, and Z planes, oh, mobiles are a vector for viruses and therefore banned in school. Okay, that could be a problem then. This might just have to be an at-home activity, either for remote teaching or maybe for homework then instead. Thank you for letting me know that. So yeah, we need to make sure that we know what planes are what with respect to our phones. So which is the X plane, which is the Y, and which is the Z. So the way that we can do that is if I pull up a new page. So the way that we do that is in that top left toolbar. There's that like page icon with a plus. I'm going to press that button. And then in my layouts on the right hand side, I'm going to scroll down to the one with 3 portrait pages on and click that one. And then I'm going to click the 1.23 in each of these displays to give us a digits display in each section. There we go. And then in the left selection measurement, I'm going to click that and then tap acceleration X. And then in the middle, I'm going to tap acceleration Y. And then on the right, acceleration Z. Right. And then I'm going to lie it down on my desk. So it's in like this orientation. Let's see if I can rotate the camera down and you can see what I'm doing. Okay. So now it's lying flat on my desk. I need to press start to start collecting data, so it's live. So you can see that now G is acting like into the desk. So that is my Z plane. So into the desk is Z coming out the back of my phone. And then say, for example, if I change orientation to here, tilt it up on its side, you can now see that G is acting in the X plane. So the X plane is coming out the side of my phone. And then in the Y plane, if we turn it up here, so that is what it would be if it's in its normal orientation, if you were like just using it for anything else normally. So that is in the Y plane, straight downwards. So that's us oriented to the phone. So as I connect this to my pendulum, I now know which orientation I'm going to have to measure the data in, so that we can measure G in the right orientation. If I try and measure it, for example, like coming out this way, it's not going to give me the right result. And again, that way, it's not going to give me the right result. It's going to have to be in the Y plane down here. Okay. Right, so I think we can get all set up and start making that pendulum. Right, so now I need to transfer you to my other camera. 1 second. Right, okay, so now you guys should be able to see my stairs. Yep, and that's a live feed, that's good. So I'm still going to keep sharing the screen from my phone so then you can see the data being collected as I record it. Grab some string. So guys, this is not a very flattering angle for me, I will admit. For those of you with a keen eye, it might look like I've swallowed some sort of basketball, but I'm actually 7 months pregnant, so I've got a little helper with me today. Not that he's doing much in there, let's be fair. But yeah, I'm expecting a baby in 2 months' time, so that might explain why I had that meltdown last week. And I can't guarantee it won't happen again this week, guys, but let's see. So what I've got here, I can't show you my command hooks, they're too high, so they're outside of the frame. But I have got a very long piece of string here, and I have tied 2 little knots in the ends, and I'm just going to hook them over the little plastic hooks that I've got on top of the door frame. Do that. I need my phone case. Where have I put that? Oh, here we go. Oh.
I can't see you, Nicola.
Oh, can you not? Thank you for telling me. Oh, can everyone else see me okay? Someone said you have to click on the video. Let's have a look. So I don't know if you've got a like a list of. For me, it's below the shared screen. You might be able to see like a list of contacts. If you're on a device, I think you can literally scroll through them with your finger. If you're on a PC, I don't quite know how it works. Tap thumbnail image. Is this making sense to anybody? Let me come back to sharing my screen. Oh, maybe not. Tap thumbnail image. Are people still having problems? Just to let me know if it toggles between the data and your feed. Ah, poo. Oh, you're spotlighted. Your video is highlighted for everyone in the meeting. Don't know who's done that, but that would be fabulous. Let me see if this thumbnail. Let me try muting my PC and unmuting my iPhone and see if that helps any. I don't know if this has helped at all. I can see you fine. I can see you. Right. Oh, I can still hear stuff. I'm getting feedback now from my own PC. Let's try that. So where's my data gone? Hang on 2 seconds. Right. So can everyone now see? Can everyone now see stairs and phone screen? Okay, we're having some thumbs up. I hope to goodness you can. I don't know. We haven't got a paid version of Teams on our work network, so I don't know if that's affecting it. I can't find any way to like make it default. Just having my feed and my my camera on there, but I'm hoping it's okay for you guys now. I can see lots of yeses, so I think we're good. Oh, I can also see lots of no, just the stairs. Okay, so it doesn't matter. What I'm going to do is I'm going to share my data again over the PC. So if you can't see it collecting in real time, don't worry. I'm going to share it over to the PC and then you'll be able to see it that way. And then also I'm going to do that shared session thing again so you can download the data after the event and you can analyse it with me in real time as well if you like. I can see lots of people pinging on the chat. 1 second. Okay.
Oh gosh, what a nightmare. I'm sorry, guys. It'll all become clear in a minute, I absolutely promise you. Right, okay, so what I'm going to do is I need to set up now a graph of just y acceleration against time. So I'm going to click on new page. I'm going to click just that one singular display up here. I'm so sorry if you can't see this. Like I say, it'll all become clear in a second. I'm going to tap that graph icon. I'm going to click select measurement and then y acceleration on that y-axis. And this is all the data previously recorded, which I don't need, so I'm just going to go in and delete all that. Delete all runs. So now we've got a nice clean graph. So what I'm going to do is I'm going to trap my this piece of string in between my phone and the phone case. Like this. So this just makes sure that it'll be a nice secure fit and it's not going to fling off as I start oscillating my phone around. So 2 seconds. Drop it in here like this, and then hopefully this is going to be nice and level. I just get down and I can see it. That looks okay. If it looks like it's slightly squiffy, what you can do is you can just tug on like either side of this string and it'll try and level it out for you. So all I need to do now is press start, and I want to collect say at least 10 oscillations. The more oscillations that you do collect, the better, but we're going to go for 10 just to keep the maths nice and simple. So we are recording at 20 Hertz, so 20 samples per second, 20 data points in 1 second. So I'm going to press start now, and then I'm going to pull my phone towards me, make sure it's nice and level, and then I'm just going to let it go. You've got quite a sway on that one. Let me just try and get it a bit more, a bit more level. So it all depends on how the angle that you bring it back at as well. So if you don't bring it back like uniformly, it'll throw you off a bit. Let me just delete that last run. Okay, and if I press start again, try again. Doesn't look too bad. That's 2, 3, 4, 5, 6, 7, 8, 9, 10, and then maybe a couple more for good luck. 1, 2. So I've just done a couple extra there just to make sure that my peaks look okay. And then I can zoom in using that 4 arrows that are all pointing outwards to the corner just on the left hand side of the graph tools. And that looks all right to me. So it looks messy at either end, but that's just because it was when I set it off and when I caught it again. But I reckon we're going to go with that for the data set. So let me come back over to the big PC and I can share this data with you guys. Right, let me come back to Teams. I'll mute this off.
Okie doke, and I need to change my camera back. Camera, where are you? Right, so here we are again. So what I'm going to do is I'm going to start a shared session from my phone. So this will let me grab my data on my PC, and then you'll be able to see it on my PC. And if you want to grab the data on your own SPARKvue, you can definitely do that too. So what I'm going to do is I'm going to click that little hamburger menu icon in the top left, and then click shared session. So I want to start a shared session from my phone. I'm going to click on that. My name is Nick. Session name, let's go for PASCO 1. So if you guys want to grab the data as well, please do feel free. All you've got to do is, I'll show you in a second. So I'm sharing that data from my phone. So now if I share my screen, just make sure you all can see that. Yeah, I'm going to come into SPARKvue. So this is what your home screen will look like. All you need to do if you want to grab my data is click on this hamburger up here, come to shared session, manually connect to an open session, type your name in here, and the session name was PASCO 1, and then click OK. So now I need to come on back on my phone, go back into SPARKvue and admit everyone. Oh, okay, so we've got lots of people wanting the data, which is fabulous. I'm going to approve all. So now if you do want the data, it's all there for you. And then in that resource booklet, I've also shared a Google Sheet where you can also get some example data from. So you're very welcome to that as well. Right, fabulous. So I can't do anything on my screen because this is a guided session. So if anyone else does want to grab the data that hasn't been able to yet, just give me a little wave and then I'll know when to come off. One thing I found from last week is it's case sensitive. Yes, it is. So that session name definitely case sensitive. So just make sure it's all in lowercase. Okay, so I've got everyone. I haven't got anyone waiting to get it, have I? If you are wanting to get the data, just let me know in the chat and I'll hang on for you. I'll just give it another 20 seconds. Right, okay, I think we're all good. Okay, so I'm going to stop the shared session from my phone. And then everyone should get a copy of that data on their own devices. Oh, that's not what I wanted. If we go to new page and then just this single one and then come to the graph icon and then select measurement and go on acceleration Y. There we go, it's all pinged up. Has everyone been able to copy that? Oh, I'm still connecting. Oh dear. Let me share it from this one just in case anyone needs it. Where are we? Shared session. PASCO 1 might be in use now if someone's still trying to connect to it, so I'll call this test 1 instead. Go yes. So if you just want to open up your shared session again and just try and rejoin to one called test 1, you should be able to grab it now. Maddie. Oh, here we go. I think that's me. Don't know what that's doing. Okay, is everyone there? And then for those of you that grabbed the data before, if you've been able to get this graph, have you been able to get it to look like this? Just want to make sure. Let's have a look. Yes. Wonderful. You're all whizzes at this now, right? After last week and this week. Okay, I think that's everyone that's got it again. Still connecting. I'm in a Wi-Fi hole. Oh God. Oh, that's a shame. We'll give you another minute, Helen, because I don't want to ruin your chances of doing it. But don't worry if you can't connect. Like I say, I'm going to ping you over some dummy data that you can have a play with. But again, if you've got some resources at home, if you've got some string that you can hang your phone from somewhere, it'll be really easy and quick to. Got some data on my phone, so I could play with that. Okay, perfect. Wonderful. So what do I need to do now? I need to stop this shared session so I can actually play with my screen. Are you sure you want to disconnect from the session? Yes. So now everybody should have that data, I'm hoping. Again, if you've got it in a weird format, because I've collected lots of things, I haven't just collected Y data, I've collected that X, Z and resultant. All you've got to do is just click on this top icon here for a new page. Click this singular graph here, come to that graph display. It'll default to time on the X-axis, which is what we want, and then on the select measurement on the Y, all you've got to do is just tap Y acceleration data. And your graph will look like this, which is the data that we want, so perfect. So we want to basically measure the length of time, so the delta X essentially, for 10 different oscillations. So I think we recorded like 12 oscillations in this data set, but you'll see there's loads more than 12 peaks here. And that really quite confused me to begin with. So you actually see 2 maxima per 1 period. And I don't know whether it's my baby brain that's taking over, but it took me a while to come to terms with that and be okay with that, because it just didn't really make any sense to me. But I'm gonna go through that with you in a second. So let's have a look at what our data looks like. So we are going to want to start on this first peak. So let me just grab grab that tool again. So this is the coordinates tool, which looks like this little crosshair, sorry. And so you just need to click on that, and then this will drag to any of the data points in your data set. So we want to concentrate on this first peak here. So if I pull that over there, we can also zoom in on that peak just to make sure that we are resting on the absolute maximum in that little range. And to do that, what you need to do is you need to press this little box down here on the selection tool. So I'm going to highlight that one, and then I'm going to draw a box just around this first peak here. So if you are following along on your own devices, on a tablet, you're probably okay. On a smartphone, it is a little bit fiddly, especially if you've got, I wouldn't say fat fingers, it struggles with my fingers. I've got fat finger problems. It is definitely doable, but it's just a bit fiddly. Let me just check there. I don't know what that was. Oh, someone's waiting in the lobby, but I think they've just been let in. Perfect. Right, so I'm zooming in on this data just to make sure we're on the absolute maximum. So I've clicked it with my little selection tool, and I'm just going to click this expand icon here so we can zoom in just on that section. So I'm going to want to plonk my coordinates tool just on the middle one, because that's the most likely of being the absolute maximum for that peak. My error on this is going to be that either of those could probably be, well, could either be the maximum as well. So my error is going to be just my sampling frequency, which is 20 Hertz. To get it into the right units, we just need to divide that, take the reciprocal of it, so it'll be 1/20 for the error on that. We'll have a look at that in a bit as well. So that's my first data point that we're going to be using. I now want to get rid of this box, so you just need to click or tap on that box and then remove that legend a bit. You can just click on that X just to remove that selection tool. And then we want to span back out, so I'm going to use this scale to fit button. And then we need to count 20 peaks on from that first one to get our 10 oscillations. But we also need a delta coordinates tool, and I don't think I showed you this this last time. But if you click on the little box that you've already got on the screen, if you click on that, it should come up with these few different options. So obviously we've got delete, we've got move right a data point and move left a data point, and then you've also got this delta symbol here. So delta is Greek for, well, we basically use it for changing or differencing. So I want to click that, and you'll see it brings up another little box. So you can click on this box and whiz it onto any other data point. So let's see how many peaks we've got here. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I think it's that peak that we need to click to. So let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20. Perfect. So again, you could use like 11 or 12. It's completely up to you, but I'm just going to use 10 to keep the maths simple. So I need to zoom in just on this section again, just to make sure I'm using the absolute maximum for that value. I've already got my selection tool selected, so I'm just going to draw a little box around this peak, and then I'm going to zoom in on it. Gosh, it could be any of these, couldn't it? Let me go for this one that's bang in the middle. That'll do. Right, and then we'll zoom back out. So this is giving me delta x, which is the change in that point to that point on the x-axis. And we've also got delta y, which we don't need for this experiment, but if you did need that, it's there for you. That tool's really handy if you're doing like a gradient, for example, or need to find out like the slope of a line. It's really, really handy for that. So this is our delta x, so that's the length of time it takes for 10 periods to take place. So we'll be using this quantity in our analysis in a second. So let's just go back to why there's 2 peaks per period in this data set. Now, I might not be the best, I'm probably definitely not the best person to be explaining this, but the way that I've kind of come to terms with it in my head is, let me show you this diagram. So this is essentially what our data looks like, just a small portion of it. So we're obviously measuring acceleration in the y plane, so downwards this way. So when the phone's in this orientation, hopefully you guys can see this in the camera feed. Let me just check, yeah. So when the phone's in this orientation, it's feeling the full G, and it's also moving at its maximum velocity. So that's where it experiences its most acceleration. That's where we're going to get that maximum acceleration when it's in this downwards orientation. So you'll see on the diagram that I've shared, this is essentially what this position is here. Here we go. So this is what this position is. So obviously this appears as a minimum on this graph, which it does on our graph as well. But I'm just talking about the magnitude here, not the direction of that vector, because acceleration is a vector, isn't it? It's got a magnitude and a direction. So the maximum occurs when the phone's in this orientation. And then obviously when it's in any other orientation, you're going to be measuring just a component of that force. So it's a component of that vertical force that you're measuring. So that's going to be, I think it's the cos of the angle. So when you times g by the cos of an angle, the cos of the angle has to take any value between 0 and 1. So when you times a number by a decimal, it's going to be smaller. So obviously everything's going to be less than that maximum, and then anything else is going to be less than the maximum. And then for one full period, it's going to have to go through that position twice, right? Because we're going to have to say if it starts here, it goes through it once on that way around, and then once when it comes back around here. So we're going to have to go through this position twice, and that's why you get that double hump feature per period. That's probably a really gobbledygook way of explaining it, but it's how I've come to terms with it myself. And there's something else that I can show you. So there's a really nice feature in PASCO Capstone. Where have I put it? I think it's in here. Can I find it? Bear with me 2 seconds. I should have put it on my desktop. Oh, here we go. So this is just looking at some video analysis in Capstone, where I've used the PASCO Smart Cart. So Capstone can't hook on to the acceleration data in your phone, unfortunately. It's just for the paid for sensors. So what you can do is you can simultaneously collect data from a sensor, and also you can collect video feed at the same time. So it's all very snazzy. It's great if you've got an experiment that's got moving parts in it and you kind of want to understand why your data looks the way it does, which is exactly what we need to do right now. So if I start playing this for you, you can also play the data back with the video feed at different speeds, so you can watch it in slow-mo, you can watch it speeded up if you needed to. You can't see the data at the minute because I've just deleted that beginning section because it looked awful where I was hanging on to it. But let's see if we can slow this down a little bit. So I'm pretty much going through the midpoint about here, which is where you can see it reaches out at the maximum, which is what we were just talking about. So you'll see that this graph is essentially the other way up from the one that I just showed you in that diagram. And it just depends on the orientation of the smart car, which one they think is plus and minus. But the theory is the same. And then as we get to its maximum point over here, you see that we'll reach a minimum where it's at its maximum angle. And then you'll see we're coming back up to that midpoint again, and it peaks out. And then maximum angle again over here, and it gets to its minimum. Wonderful. So you can really kind of understand exactly why your data looks the way it does with respect to the video. You can do this at really high frame rates if you want to capture something in a really good resolution, but it's a really nice handy tool that we might be able to include in a webinar at a later date. Let's come back to, I'm just going to close this down so my data capture doesn't get confused between the two systems. Come back to SPARKvue. Right, okay. So instead of plugging all this stuff into a calculator, I am going to just shove it in an Excel file that I've just made up. So my delta x, which is that time for 10 periods, actually no, I've told it to ask for, well, we'll do that, 25.85 seconds. So it's going to divide it by 10 to get t, just the one period for me. And then the other thing it needs is the length, which I didn't take, did I? I'm going to have to just nip over there and do that, 2 seconds. Who's waiting in the lobby? I'll just admit this person. Let me turn my camera on so you know I haven't disappeared. Take you back over to this one. Hang my phone back up. So I haven't taken the string off my phone, so the measurement will be exactly the same. Down here. And then I just need to get my tape measure and just measure from top of the door frame to here. I get that to be 162.1, I think. 162.1. Let me write that down before I forget. 162.1, and that's in centimetres. So I'll have to convert that. Let me turn my camera back on. Not hide device settings. Back to this one. Here we go. Right, so where's my Google Sheet gone? So L. So the full length from the top of the door frame to the top of my phone, I got to be 162. Oh no, I need to divide that. So that'll be 1.621 meters. And then I need to minus off the distance from the top of the door frame to the actual hook, which was 0.059. And then I also need to add on half of my phone, because remember, the length goes to the center of mass of the object that's swinging, of the pendulum. So I need to then add on half of that phone length, which is half of 0.156 meters. 0.156 divided by. And then this should calculate G for me, and let's hope it's something reasonable. Oh, 9.69, that's really good, right? So it should be 9.81, and we've got 9.69, and that the percentage error on G is going to be 1.23, so that's super, super accurate. And you mean I collected that data once, right? And it's worked really well. So again, if you want to try this at home, try and replicate it. I guarantee you'll get a super good result like I did. I have done this 1,000 times in preparation for today. But I mean, there's lots of different ways that you can do it as well. You don't necessarily have to do it in the same orientation that I did. If you want to, say, for example, make a little hammock for your phone and record acceleration, what will that be in, like in the Z direction? You could do it that way. I mean, there's so many different ways that you can get your students to explore doing this experiment with experimental design. You can get them getting creative on their own terms. But yes, I think that's pretty much everything that I wanted to show you today. If you guys want to come off mute and ask me any questions, then we're good to go. Oh, I did mention as well, we can make it a bit more complicated. So our data looks like this. Oh, not that. So you can see that we've got this kind of like decaying function. So if you did want to make it a little bit more complicated, you could get your students to fit a certain function to this data and have a look at how it decays. I think you can either use just the like amplitude of these peaks and then use an exponential function, or you can fit like a cos function to it and do it that way. But I mean, there's lots of different ways that you can kind of explore some of the kinetics around this. And make it a bit more of an in-depth investigation for your students. But in terms of those like lower level students, if you wanted to get them to do it, I don't think it was really too complicated, especially if you were, for example, to give them this spreadsheet as well, where they've literally just got to type in a few numbers and it'll ping the answer out for them. I'll give you a copy of the spreadsheet as well, so you've got it for your own records. I only really used it today to save me from typing all the numbers into a calculator and maybe getting an error. So it's just a nice, easy way of pinging out the number really readily for you. I have worked out all the errors. You've got to put the errors in here, but it will propagate the errors for you through these formulas. So all of that's done for you as well. I'll write all of that out explicitly in the resource booklet so that you've got that information. But yeah, I think that's me sorted. So yeah, if you've got any questions, please do come off mute and and let me know what they are. Thank you very much for watching. I hope it's been useful.
Thank you, that's been really useful. Can you show me how you connect the phone to the piece of string?
Yeah, of course. So let me go through it. So this is how it's connected now. This is what it looks like now. But what I've basically done, I couldn't think of a better way of doing it, to be honest. So when it's all when the string's suspended from wherever you want to suspend it from, it makes like this kind of cradle. So all I do is I put my phone in the bottom of that cradle, make sure it's nice and level. And then can I do this just one hand? So it's like that. And then what I do is I just trap my phone case around it. So it does depend on having a phone case, this method, but then you can like trap it in there. And that's a really nice secure fit now. That is not going to come out of there easily.
Okay, thank you.
I would recommend that if you are doing this at home, or if you encourage students to do it at home, that they put some like cushioning down on the floor, just in case they haven't got a secure way of suspending their phone properly. And then if it does fall, it'll land on a nice cushioned surface, so it's not going to break the phone or anything. If they've got a nice long pendulum as well, it should be relatively close to the floor anyway. But I mean, I've done loads of things with my phone and not managed to break it yet, so it should be absolutely fine.
Okay, wonderful, thank you.
Yeah, no problem. The postman's just been to my house. Have we got any more questions while we're here? Oh, I can see my chat. Let me have a look at the chat. Would it be possible to have the other webinar recordings? Absolutely, yep. I will make sure that our marketing team send around an email with all the links to those. So that'll be no problem at all. No problem. Thank you all very much for attending. What are the plans for the next session? So I think I haven't actually seen the feedback from the last sessions. I've heard it's good, so that's fantastic. Thank you all very much. But in terms of what we're going to be doing next time, I think we're just going to do an introduction to wireless data logging with the PASCO paid for sensors. So we'll probably look at the most popular ones that we've sold and go through those first. So I think that's what we're going to do for the next one. So that'll be like the wireless temperature sensor, wireless pH. What else have I got? It'll all depend on what kit that I've got in my cupboard as well. It probably is a good idea to do a session on light gates. I don't know what people think about that, but it's definitely one that I get asked a lot of questions about. Data logging is always a failure. Oh no. I promise it can be super, super easy. So yeah, we'll definitely get those issues sorted out. Have you tried your dongle, Philip? Perfect. Yeah, we'll definitely do one on light gates then. That's good. PASCO have got lots of different options for light gates, and they're not known for being the cheapest. So I want to kind of explain why that is.
I haven't tried the dongle yet.
Oh, okay.
I have it. It's still on my to-do list. It's that desperate that it's plugged. It's right next to where I need to do it. It just people keep wanting to do other things.
Right. Yeah, that's no problem. At least you've got it now. So
that'll be brilliant. Light gates would also be wonderful. It's the sort of very common things that we have to do.
Yeah.
For me, data logging lasts only a few minutes, and then I wonder why it hasn't logged, and I don't know what I've done wrong. So it's something probably really simple, and you'll show me, and I'll go, oh, I was supposed to click that.
Okay. Is that using a particular sensor, Philip, or just in general?
Oh, that's absolutely in general. I've tried the weather sensor. That's really good. By the time I normally run in from putting it on outside, it's stopped logging.
Right, okay. Yeah, that weather sensor is amazing. It's like a little weather station on its own, isn't it?
Brilliant.
I love it. Temp and pH will be useful. Excellent. I'd definitely argue that PASCO is the best system out there. Obviously, I'm going to say that, but if you do your own research, you'll find that we actually come up trumps with respect to both spec and pricing, and you get the free 5-year warranty with us, and you get to work with me, so it's win-win all round. Thank you. Repeating T-determination experiment with the light gates would be good. Yep, absolutely. So the 2 CPACs that we'd go through with the light gates would be G by freefall, and what's the other one? F equals ma, Newton's second law. So we'll be looking specifically at both of those when we do the light gates. Yeah, I don't know why it's such a product that causes so much confusion. I think I guess it's just a very physicsy thing, and with a lot of people not having a background in physics, it might just be a kind of alien thing. But no, they're super easy. So to kind of get some myth busting going with the light gates would be a good option. Yeah, definitely. We'll do that. This one was better than last one. That's good. I enjoyed this one. I hope you guys did too. It's nice to do something a bit more experimental where you actually determine something and you can see how good the equipment works. And again, that's completely for free. So yeah, it's great. Yeah, Claire, not to worry. So if you just register for the webinars, what we'll do is we'll ping you across all the information. So you'll get the resource booklet, you'll get the link to the webinar for real time, and you also get a link to the recording afterwards. So you'll have all of that information. If you can't watch it in real time, that's fine. Don't worry, you can always watch it offline in your own time. And all the best for going back into the prep room. I use 1/2 meter rule to drop through so that we can get a V within the gates and between gates. Use a 1/2 meter rule. Oh, okay, I think I get what you mean. Yeah, so there's a couple of different ways that you can do geography freefall, isn't there? You can either just use one flag, either like a ball or I guess a ruler, and then drop it through 2 gates. And there's another way that you can do it just using a picket fence and just 1 light gate. And I think a lot of people aren't actually aware of how you do that one, but it is the cheapest way to do that experiment. It's a little bit more tricksy in terms of getting to grips with what's actually happening in the experiment, but it makes it, I don't know, like 50 quid cheaper per set. So yeah, I'll run you through a couple of ways of doing that one. Have we got any more questions while I'm still here? Is there one next week? Yeah, again, so we'll be doing it on Thursday at 2 o'clock again next week. I think we'll send out an email, follow-up email tomorrow, and it'll have the link to register. All you've got to do is just click on that and you'll be registered for it. Thank you. See you then. Thank you. Is there anyone else left that wants to ask any questions? You might just have wandered away from your PCs, and I fully appreciate that. I understand an hour's worth of a webinar is can be quite daunting, especially when you've got other stuff to do. Is there anything else I can help you with? It's just me and you now.